Alright, so in my previous video, the hangover hair scram, I started noticing a knocking noise, a real loud knocking noise at the end of the second lap. And this video is going to be like a how to diagnose your noise and how to fix it. But let's rewind things. This is when I first noticed the noise a week prior to the race.
Something ain't right. This thing's holding back or something.
Here's a cell phone video that really highlights the noise. You'll have to excuse the video is really crappy, but you can hear the noise really well. So with my noise, you can hear it sounds like a bunch of bearings or hammers tapping on the top end of the engine. The noise does not change when you pull in the clutch. When I tore it down to diagnose it, I took the head off and I noticed a ton of play in the top of the piston. I could move the piston back and forth inside the jug. So I unbolted the jug, pulled the jug off, and I pulled the circlip off the wrist pin, and the wrist pin bearing, once I slid the wrist pin out, the wrist pin bearing fell apart in my hand. That play in turn wore the top ring down because it allowed the piston to move back and forth, and it also scraped a little bit of the Nickel coating off the jug. Technically, I should replace this jug at this point, or have it re-Nickel coated, but I did take some bore measurements. It's mostly within spec, so as of right now, with this top end job, I'm just going to reuse this jug for this point, and the next top end I do, I'm going to go ahead and replace this jug. So after inspecting the piston for wear, you can see there's wear down on the bottom skirts here, and it appears to have been piston slap. What appears to have happened is I had a catastrophic failure, so to speak, in the wrist pin bearing, allowing the bottom of the piston to strike the skirt. You can see where it's rubbed on the bottom of the skirt on both sides here. So diagnose complete, piston slap. I ended up actually checking the bottom end here. We're checking for up and down movement. We checked axial play, and how you do that is you take your feeler gauges and you stick them in between the rod and the crank there, and the service limit for this bike is 0.6 to 0.7 millimeter. So yeah, that's good. Now let's move on to the repair. With this video, I didn't want to go into step-by-step detail of how to do this job because there are plenty of top-end rebuilds on YouTube. However, I've watched several of them, and I've noticed one common theme. They've left out a couple very key details, which I'm going to mention in this video. So here we are with all of our surfaces cleaned up already. I skipped over that part for the purpose of shortening this video, but you want to use cleaners like brake clean, engine degreaser. You want to make sure your base gasket is scraped completely. There's no like leftover film on it. And one of the first things I like to do when I'm doing an engine is ring gap. I feel it is one of the most important specifications when you're rebuilding an engine. If your ring gap is too loose, you'll have lower compression, but you won't have a catastrophic failure. If your ring gap is too tight, you will have a catastrophic failure. Now, interestingly enough, there's a couple main manufacturers for this particular bike, Vertex and Wiseco. Now, both of these manufacturers have different specifications for ring in gap. The manufacturer OEM specification for the ring gap is 0.4 millimeters or 0.0157 inches. So when I look at Vertex's pistons, they recommend a ring gap of right around the same as manufacturer specifications, and they give you this formula in order to calculate your ring gap to check it. Now, if you take a look at Wiseco's piston ring gap specification, they want a tighter specification. In their formula, they're using a times mark of 0.004. So this is very important. The reason why there's a different specification between the two pistons is the materials that the ring is actually made out of, the ring and piston itself. So different alloys expand and contract at different rates, and that is very important to note. One thing I have to note, both the rings were in spec already in the kit, so you shouldn't have to do any ring grinding. So now that I've taken 50 minutes to explain why ring in gap is important, let's actually put the ring on the piston. So with this particular two-stroke engine, there's two rings, and the rings have a letter on them. The letter goes facing upward. Put your ring on, make sure the ring gap is where the pin would be. Now it's time to install the piston onto the rod. Go ahead and put your circlip in on one side. Pre-oil your wrist pin and wrist pin bearing with some pre-lube. Some two-stroke oil will do. I'm using BG pre-lube. It's important to note that there's an arrow on top of the piston, and that arrow
faces towards the exhaust port.
So 3 hours into this video later, and we're finally selecting the base gasket. Your base gasket selection actually will control your squish depth and compression. So the stock OEM base gasket is 0.32 inches in the non-squished area. The gasket kit I got came with several different gaskets. The largest in the kit was a 0.03 inch, so I just used that one. Now I'm going to slide the jug over the piston and torque it down. The jug torque is 25.81 foot-pounds torque, and the head torque is 19.91 foot-pounds torque. Quick note too, the nuts on the jug, you can't actually get a torque wrench in there. A couple things you can do is tighten it down a little bit and then kind of get the feel from the other side using a torque wrench. You can kind of count your turn as far as degrees, you know, or you could use a tool called a crow's foot, which is basically an open-end wrench with the ability to put like a 3/8 or a half-inch drive on it and just torque it down that way. One last thing I like to do is check the power valve to piston clearance with a feeler gauge before I install the head. Sum it all back together, cross your fingers you did it right, and yeah, kick it. See what happens.
First kick. Ha! How do you like it now? Alright. Noise is gone. No noise. That's what we wanted to hear. Let's let this thing get up to operating temperature and go from there.
So for my next video, we're going to do the break-in procedure on this thing, so stay tuned for that. And yeah, I will catch you then. Peace.